Hello learners, welcome to this course on Embedded System Design using PIC16F877 Microcontroller. So in this tutorial, I will be discussing about on implementing a LED train using PIC16F877 Microcontroller. So for this project, we will be using MicroC Pro for PIC as an integrated development environment, and we will be using Proteus 8 Professional as a simulator. So here the logic behind this program is we are going to connect an LED array, a group of LEDs into PIC16F877 microcontroller to port D RD7 to RD0, and we want to light up the LED in a particular sequence in a train fashion. So for example, in the first state, we have the first LED to be in on state, all the other LEDs will be in off state. And after some time, the second LED will be on and all the other LEDs will be off. Then subsequently, third LED, fourth LED, fifth LED, sixth LED, seventh LED, eighth LED will be in on state. Remaining LEDs will be in off state. So at a particular point of time, only one LED out of 8 LEDs will be in a on state. So it looks like something like a LED is moving from one point to the another point. So that is why we call it as a LED train. So in order to do this programming, we have two registers associated with the port D. One is data direction register, another one is a buffer register. So data direction register for port D is TRISD. So each bit of this data direction register is assigned for a particular pin. For example, the 0th bit is for RD0. Same way, first bit is for RD1. So same way, 7th bit is for RD7. So if I put a value of 0 in this bit position, we can configure the particular pin as an output pin. If I specify it as 1, it will be an input pin. So that is how we can define a particular port pin as an output pin or an input pin. Then in order to send a logic to a particular port pin, we make use of the buffer register. So again, it's an 8-bit register. So each bit is assigned with a pin. So by putting a logic 0 onto this bit position, we provide 0 volt at that pin. By providing 1 to that bit position, we provide 5 volt to the pin. Now let us see how to do this programming part. So we will be creating the hardware in a Proteus 8 Professional software, and we will be writing our embedded C program in MicroC Pro for PIC. Let us open the Proteus Professional software where we will be building our hardware. So first let me create a new project. Specify the location for the project. So I will create a folder LED train. So in that I am going to put my project, give a name for the project. So two things we are doing here. One is putting a location to the project, and another one is giving a name for the project. Press next. We need to select a schematic of certain sizes. So we can use a default schematic where we will be putting our circuit. We are not going to create any PCB layout, so I am going to leave it as it is. Press next. We are not going to use a firmware. Next. Finish. So before finish, you can see that only schematic has been selected. Press finish. So it will open this window where we are going to build our circuit. So we select the components first. Go to this P, which gives PIC devices. So here first thing I require is PIC16F877 microcontroller. Add it to your list, so it gets added. When you double click on the component, it will get added to your list. Same way I require a bar graph LED, which is nothing but an array of LEDs. So here you can see I have 10 LEDs connected in a single unit. So double click on it, it will get added. I require a crystal. Add it to your device list. Capacitor. Add it to your list. Resistor. Add it to the list. Switch. Add it to the list. So these are the components which I require for this project. So I have selected all the components like a microcontroller, bar graph LED, crystal oscillator, capacitor, resistor and a switch. So once we have done with the component selection, press OK to come out of this window. So now we have all the components here on the left side. We have to use these components to build the circuit. So first let me select the microcontroller, place it onto your circuit. Now let us put the bar graph LED to port D. So I am going to place it near the port D. Here you can find the port D RD0 to RD7 where we are going to connect this LED. So here I have 10 LEDs but we are going to use only 8 LEDs out of it. The pin number 1 to 10 represents the anode of the LEDs. Pin number 11 to 20 represent the cathode of the LEDs. So I am going to connect RD0 to pin number 1 of LED bar graph. Same way I am going to connect all the 8 LEDs RD0 to RD7 to the LEDs in the bar graph. So once I connected all the anodes, I want to connect the cathodes. So I can go to this left side, pick up terminals mode, ground, place it onto your circuit. So connect all the cathodes to the ground. So now I am going to connect the oscillator circuit. Again, to select the component, go to the components mode on the left side. Press components mode. Select the crystal. I want to rotate this crystal. So I can use the option here, rotate clockwise to rotate the crystal and place it onto your circuit. Then I can connect this to pin number 13, which is the oscillator 1 pin. And pin number 14 is another oscillator pin. Then in order to get a stable square waveform from the crystal, we need to connect the capacitor of 33 picofarad. So again let me rotate it and place it onto the circuit. So connect to the two ends of the capacitor crystal. So again the other end of the capacitor should be grounded. So I go to terminals mode, press ground, put it onto the circuit, then connect the capacitors. So this capacitor should be of either 33 picofarad or 22 picofarad. So I am going to select it as 33 picofarad. So select the component, right click on it, edit properties, where you can change the value for the capacitor. So I am going to put 33 picofarad. Okay. Same way, select the another capacitor, right click, edit properties, 33 picofarad. So the crystal frequency should be set. Again, right click on the crystal, edit properties. So here I will specify it as 10 megahertz. So up to 20 megahertz we can provide the crystal frequency for your microcontroller. So I am going to set 10 megahertz and this frequency should match with the program frequency. Press OK. So now I am going to put the reset circuit. So for putting the reset circuit, again I am going to the components mode. Select the switch. I am going to rotate the switch. Put it onto my circuit. Then take a resistor. Put it onto the circuit. Connect one end of the resistor with the switch. So one end of the resistor I am going to connect to the power. So power again you can get it from the terminals mode. Place it onto your circuit. Connect it here. Ground. Put it onto the circuit and connect it to the switch. Now this memory clear pin, it's an active low pin. So which is a reset pin, needs to be connected to my circuit here. So whenever we supply voltage to this circuit, what happens? This pin will be at logic 5 since it is connected to a power supply. So the microcontroller will not be in a reset state. As soon as I close the switch, what happens? The current flows towards the ground. So thereby this terminal will become ground, 0 volt. So then the microcontroller will become reset state. So we can remove the switch. So this is the reset part. This is the oscillator part. So now we have built the circuit. Let us save the circuit. So we have saved the circuit in a LED_train. So now let us go to the programming part. So we have built the circuit. Now we have to build the program. And we have to create the hexadecimal file. Then that hexadecimal file can be ported onto this microcontroller program memory. Then we can check the logic. So let us go to the program part. Let us open MicroC Pro for PIC. First thing, here also we have to create a new project. So new project, standard project. Next, again select a location for our project. So here let me put it as LED train. Project name I'm going to give LED train. So again the controller we can select from this drop down menu. So lot of controllers are there. You can select of your choice. So I'm going to use PIC16F877. Let me select it, and the oscillator frequency, it should match with the hardware circuit. So there we have given 10 megahertz. So here also I'm going to specify it as 10 megahertz. So 4 things we are doing here. One is choosing a location for our project, then giving a name for the project, select the microcontroller which we are going to program, and select the device frequency. Press next. We don't have any files right now, so I'm going to leave as it is, finish. So this is the window where we are going to write our code. So this is the project manager where you can find all the files. So our project name is LED_train. In that we have the source file LED_train.c. Here you can see the project settings, the microcontroller and oscillator frequency as we said. Here we have the micro libraries. So right now we are not going to use any libraries, so it is empty. So let me copy this program and place it onto our circuit. So here first we start with main function. So any C program will have a main function. So we don't have a return type here. So we have specified it as void, and there is also no input argument. So it is empty brackets. So here I am going to declare a character variable, unsigned character I, and I initialize it to 0. Since we have connected the bar graph LED to port D, first we need to specify the port D as output port. For that I am going to make use it of trisD. So trisD equal to 0x00, which means we put 0000 0000. So 8 zeros. It's a hexadecimal number is represented by this 0x. So first 0 represents 4 zeros, next 0 represents another 4 zeros. So since we have configured all the port pins to be 0, which means all the port pins are configured as output pins. Then we initialize the port D to be 00, which means all the LEDs will be in off state. Then in a while loop, which has a condition true, so will get executed infinite number of times. So this statements will get executed infinite number of times. So here I am going to use a for loop where I changes from 0 less than or equal to 7, because we need to move from one position to the next position. So I am going to have I equal to 0, I less than or equal to 7, I plus plus. What we are going to do? Port D first initialized with 0x80. So 0x80 in the sense 1 0 0 0 0, 0, 0, 0. So only this port D7, RD7 LED will glow, all the LEDs will be in off state. So in the initial condition, this is the right shift operation. So I'm going to do a right shift of this data by I. So I, when the for loop runs for the first time, I will be 0. Which means we are not going to do any shift. So only the RD7 will get lightened up. And in the second time, when the for loop runs, now the I value will be 1. So when the I value is 1, now we are going to do this data right shift by 1 time. So which means it will go to the second position, RD6 position. When it runs for the third time, it will go to the next position. Then subsequent times, slowly it will move to the corresponding positions. So finally, we check whether our port D has reached 0x01. Because after this, when I shift it, our port D will become 00. So in order to avoid that, I am going to check whether our port D has become 0x01. If it is so, again I am initializing it with 0x80. And I is also set with the value of 0. Since this statement is with delay function, we can able to physically see the output for 1 second. So we can see the LED in a particular position is on for 1 second, then it goes to the next position. Again it is on for 1 second, then it goes to the next position. So like that we can see a movement of LED in the bar graph LED. So this is how we can design an LED train. So let us save the program. Now we want to convert this program into a hexadecimal file or an opcode file. So for that I will be using the build operation. So build, it gets converted. So there are no errors. So it gets converted. So now let us go and see the folder location. So in work, you have PIC MicroC. You can see the hexadecimal file here. So when I open this with Notepad, you can see the corresponding hexadecimal file for our embedded C program. So this is the file which we are going to put it onto our Proteus environment. Now let us put this hexadecimal file into the Proteus environment. We open Proteus, right click on the IC, go to edit properties, select the processor clock frequency, it is 10 MHz, then select the program file. So for program file, you go to PIC MicroC LED train. This is the X file which we are going to import onto our microcontroller. Press OK. So now we have imported the file onto the program memory of your microcontroller. Now we want to check the logic, whether it is working properly or not. So to do that, we can press this play button. So when I press this play button, you can see it starts. So it goes to the subsequent position and it remains there for 1 second, then it goes to the next position. So like that it continues till this RD0 LED, then again it will start from RD7. So it goes on like this. So this is a very simple design of LED tray using PIC16F877 Microcontroller. So in this tutorial, I have talked about how to design a LED train using PIC16F877 microcontroller. Thanks for watching. Please subscribe for more technical learning. Thank you.